Good morning, 10th standard. Today we shall start with the next chapter, chapter number 15, probability. Before you start with watching this video, it's better that you note down the work which I have shared with you in the group. Note down the work done in your notebook and then watch this video so that you can note down the examples side by side which I mentioned during my video. So first of all, let us take up what probability of an event means. So every time we use the word probability, we'll be using the word event with it. So you will always refer to probability of an event. Event is something that is possible to happen. It may happen, it may not happen, or there is a certain chance that it will happen. You were introduced to probability for the first time in 7th standard, and you came to know that probability is measured in 3 ways. Either an event will definitely happen, or an event will not at all happen, or it may happen. So when we want to measure what are the chances of that happening, we express that using probability. So if you want to know whether it will be a sunny day tomorrow or what are the chances that it will be a windy day tomorrow, you will be expressing those chances in terms of probability. There are two types of probability. The first one is empirical or experimental probability. The second one is classical or theoretical probability. Now, when you were first introduced to probability in 7th standard, since then you have been doing questions based on probability. In 7th and 8th standard, the questions that you did were directly based on classical or theoretical probability, whereas the questions that you did last year in 9th standard, they were based on empirical or experimental probability. Now, what is the difference between these two? In case of experimental probability, the probability depends on the outcomes of an experiment. For example, let us say there is an experiment performed in which a coin is tossed 1000 times and then it is noted down how many times heads and tails appeared. So the frequencies of the outcomes were noted down. So let us say out of 1000 times, so 1000 is the total number of times the coin was tossed. So this will be total number of trials. So total number of trials is 1000, and out of which heads appeared 455 times and tails appeared 545 times. So this is something which was given to you in the form of a table. You were already told that how many total number of trials were performed, and out of those trials, how many times you got particular outcomes. Based on this record or the data, you were asked to find out the probability. So based on this record or this data, if I ask you what is the probability of getting H the next time a trial is performed or the next time the coin is tossed, then you would use this 455 out of a total of 1000. So that will tell you what probability is. And this type of probability where an experiment was performed, the total number of trials is given to us, and out of those total number of trials, how many times various outcomes happened is already given to us, and we use those results to write down the probability. That probability is called experimental probability. Now, what is theoretical probability? If you look closely, what happens when we are continuously doing these trials or these experiments, we can observe that every time the coin is tossed, and as the number of trials increase or the number of the tosses increase, the experimental probability of getting heads and tails gets closer to 1/2. So if you look, these are very close, 455 by 1000, and the probability of getting tails is 545 by 1000. Both of them are very close to 1/2. So as the number of trials increase, if suppose we did this trial 2000 times, then these numbers would probably be very close and their probabilities would be 1 by 2 or closer to 1 by 2. And that is something we assume, theoretically speaking, that when a coin is tossed, the probability of getting a heads and a tails is equal. And if we consider that, then the total outcomes is 2. Either heads can happen or tails can happen. So heads appears once, tails appears once. Out of 2 results, there is one result which will give us heads and the second side will give us tails. So if we calculate the probability based on this, that is called theoretical probability. After this, we have a term which we will be using a lot many times, equally likely outcomes. So if there is any experiment performed and its outcomes have the same probability, then the outcomes are called equally likely outcomes. Equally likely outcomes means the outcomes which are whose probability is equal. The word likely means something that can happen, the chances of occurrence. So outcomes with equal chances of occurrence are called equally likely outcomes. Now for this, you could consider the outcomes of rolling a die. When you roll a die, the possible outcomes are 1, 2, 3, 4, 5, 6. Your normal die, the one you play Ludo with. So these are the outcomes which will happen when you roll a die. Now if you want to write down the probability from here, what is the probability that you will get 1? So out of the 6 faces of the die, there is just one face which has 1 on it. So the probability of getting 1 is 1 by 6. What will be the probability of getting 2? Out of 6, there is one face with 2 marked on it. So the probability will be 1 out of 6. Similarly for the remaining 4 numbers. Or you could take it in a different way. Let us write down what will be the probability of getting an even number. So even numbers are 2, 4 and 6. So there are 3 even numbers out of 6. And if we want to know the odd numbers, there are 3 odd numbers out of 6. Now they have the equal probability. So the outcomes in which we want to note down that the outcome will be an even number or the outcome will be an odd number, these are equally likely outcomes. Now speaking in terms of the formula that we use to find out the probability, these are the 2 empirical and the classical probabilities that we will discuss about. This is something we used last year when we were given the total number of trials of an experiment, and if we were measuring the probability for any one of the outcomes, what we will do is the total number of trials will be in the denominator and the event which we are referring to, its outcomes will be written in the numerator. Again, I'll take the same example which I mentioned earlier. If the total number of trials was 1000 and the number of heads is 455 and the number of tails is 545, and if I want to measure the probability of getting heads, so the probability of getting heads will be given by 455 over 1000. And if I had to measure the probability of getting tails, then the probability will be 545 over 1000. I simply have to use the values which are already given to me. I don't have to think about anything else. So use the values given in the table and write down the probability. That is empirical or the experimental probability. Now coming to this side, classical probability. If I have to write down the probability of any of the outcomes, so let us consider again tossing a coin. So if a coin is tossed, what I can get is I can get either a heads or I can get tails. So these are the 2 possible outcomes when a coin is tossed. So if I want to write down the probability of getting heads, so out of 2 there is one outcome in favor of heads. So these are the two outcomes. One is in favor of heads, so 1 by 2. Same way, probability of getting tails will also be 1 by 2. So this is how we have been dealing with these. You have used this in 7th and 8th standard. This you have done in 9th standard. And this year we will again be working with the concept of classical probability. Now, after you are aware of what empirical and classical probability is, you need to know something about the word sample space. Sample space means when we list all possible outcomes of any experiment. So I have done that already. The list is itself called sample space, and it is represented by capital S, and the list is written in curly brackets. So if I want to write down the outcomes of rolling a die or the outcomes of tossing a coin, I will list those outcomes in curly brackets, and I want to make sure that I have listed all possible outcomes. So this is important. I want to note down all possible outcomes for any experiment. So if I want to note down the sample space for tossing a coin, so a coin is tossed, the sample space will be either I'll get heads represented by capital H, or I'll get tails represented by capital T. Now if we have a die is rolled, so the sample space in this case will be the list of numbers that will appear on the faces of the die. So 1, 2, 3, 4, 5, 6. Now there were questions last year in which we discussed when 2 coins are tossed or 3 coins are tossed. You might be asked to write down the sample space for the same. I want you to try that. Let me know if you remember how to write down the sample space when 2 coins are tossed. So 2 coins are tossed together, or 1 coin is tossed 2 times. So 1 coin tossed twice, or 2 coins tossed simultaneously. So the sample space for this, so you will get heads on both, heads on the first coin, heads on the second coin. Then the next possibility is there is heads on the first coin but tails on the second one. The third possibility is you get tails on the first coin, heads on the first one. You're supposed to write this together, and then finally you have tails on both. So there are 4 possible outcomes, and we have listed them together. This gives the sample space when 1 coin is tossed twice, or 2 coins are tossed simultaneously. Similarly, you can write for 3 coins, and also try writing the sample space when 2 dice are rolled. If you roll 2 dice together, what will be the sample space? You will come across questions where you will need this. Moving further, so once you have written the probability using this fact, because we will be working with classical probability, so if you have written the probability of any event, there are certain facts that we need to remember, and that is what we're going to discuss next. The first fact that we have is sum of the probabilities of all the elementary events of an experiment is 1. So if any experiment is performed and all its outcomes are noted down, all those outcomes are its elementary events. Now let us consider that there is a bag. It contains a certain number of balls. There are 2 yellow balls, there are 3 red balls, and there are 7 blue balls. So that means there is a total of 12 balls in the bag. If a ball is drawn at random, a ball is taken out at random from the bag, then I want to know what is the probability that the ball will be yellow. Second case, I want to know what is the probability that the ball will be red. And the third case, I want to know what is the probability that the ball I have taken out of the bag is blue. So if for the first case, I can write the probability of getting a yellow ball. This will be given by total 12 balls I can draw, or I can take out 12 balls, out of which 2 are yellow. Then for the red ball, again I've got 12 balls, out of which 3 are red. Then for the blue balls, total 12 balls, and I can draw out 7 blue balls. Now these are the elementary events. If you look at the sum of these, if you add these, the sum will be 1. Let's quickly check that. 2 by 12 plus 3 by 12 plus 7 by 12. So denominator is same for the 3. The numerators added together give you 12 by 12, and this is 1. So this is what it means for any experiment. If we write down the probability of all its outcomes and then we add those probabilities, you don't have to add the outcomes, you have to add the probabilities, the sum will be 1. Now second case, if E is an event, then E bar represents not event E. An example could be, suppose there is a match going on and E represents the event that the player will hit a boundary. Then not event E bar will mean that the player does not hit a boundary. So E, player hits a boundary, E bar, player does not hit a boundary. In that case, we call the events as complementary events, and what is special about their probabilities is that the sum of their probabilities is also 1. Now consider an example where a die is rolled. So if a die is rolled, probability of getting 5, so I'm taking it random, and the probability of not getting 5. So if you want to know what is the probability of getting 5 when a die is rolled, this will be 1 out of 6. There is one face on which 5 is marked, and there are total 6 possibilities. So out of 6, 1 is in favor of 5. The probability is 1 by 5. And what is the probability of not getting 5? So the probability of not getting 5 means we could have any of the other remaining numbers. So out of 6, 1 has 5 and the remaining have a number which is not 5. So that will be 5 by 6. So if you add these two, the total is 1. So this is something we usually actually directly use. If you have been given the probability that a team wins, you have to find out the probability that the team loses. So probability of winning is given, you have to find out the probability of losing. So losing actually means not winning. So what you will do, you will use this relation, probability of winning plus probability of not winning equals to 1. Use the probability of winning here and calculate the probability of not winning, and you will get your answer. Third fact is 0 less than equal to probability of an event E less than equal to 1. This means the value of probability ranges from 0 to 1. The minimum value of probability of any event will be 0 and the maximum value will be 1. So it will either be 0, the minimum value, or it will be 1, the maximum value, or it will be somewhere between 0 and 1. And somewhere between 0 and 1 means there will be a proper fraction. So proper fraction is in which the numerator is smaller than the denominator. So this is something you can actually keep in mind while calculating the probability in case this is not the case for the answer that you have written. That means there is a mistake. Based on this, we have special types of events. If the probability is 0, the minimum probability, that means the event is impossible. And if the probability is 1, then we call the event as sure event or certain event.